Hello and Assalamualaikum. We are from Group 2. So today we will be presenting on our group project, which is the undertaken for the development of Nalanda University new campus.
Here is our content, which is we will cover for introduction, background study, project information, design information, analysis, and conclusion.
Hello. So firstly, my name is Nurul Ashimi Zakaria and my matrix number is CF220215. So I will have a talk about the introduction of the company background. So firstly, our company name is Soitbit Consultants Sdn Berhad, and it play a crucial role in this project. So let me introduce our company briefly. So we are Kuala Lumpur-based consulting firm, and it's specialized in deep piling, ground improvements, and substructure design. So our mission is to provide a reliable, cost-effective consulting services that foster trust and transparency with our client. So for this project, our innovative solutions were instrumental in tackling the challenges of designing a robust and durable foundation for Nalanda University new campus. So for the company background, our company brings decades of experience to the table. So we focus on delivering a practical, innovative solutions that tailor to the unique demands of each project. So for this campus, we utilize advanced geotechnical engineering technique, and it is to ensure the stability and longevity to all of the structure. So this presentation highlight our methodology and results that showing how we contributed to a safe and sustainable design. Then for the next slide is the background of the study. So this project was a geotechnical study for Nalanda University new campus, which located in Rajgir, Bihar. So it involved a multi-story building, roads, and essential infrastructure. So to support the project, we drilled three boreholes up to 70 meters deep to assess the subsurface conditions, and key tests, including the standard penetration test, were conducted to evaluate the soil strength and frictions. So this allow us to calculate the soil weight bearing capacity and ensure the settlement stability. And ultimately, we concluded that the soil is safe for construction and capable of supporting the planned loads without significant movement or sinking. Then let's move on to the next slide, which is structure project. So firstly, let's focus on the project location, Rajgir, Bihar. So it is a site of historical and cultural significance, which make it an ideal location for Nalanda University. However, the region-varied soil condition required a true geotechnical assessment to ensure that the structure would be safe and durable. So this study is a key step in preserving the legacy of this important institution while supporting its growth. So next, let's talk about the specific technical aspect of the project. So several critical tests were conducted during our investigations. So this include the standard penetration test to evaluate the soil strength and density, and laboratory tests to analyze the properties like friction angle and under shear strength. So using this data, we calculated the soil safe bearing capacity and conducted settlement analysis. So next for the roads, we performed a California bearing ratio test to confirm the soil suitability for constructing long-lasting and durable roadways. So together, this analysis provided the foundation for a stable and resilient infrastructure. Thank you.
My name is Sherlina and I will be talking about the project information. So the project goal is to study and conduct a geotechnical assessment for the foundation design of Nalanda University proposed new campus in Dakgir, District Nalanda, Bihar. Ground engineering risks are widely acknowledged as significant element in influencing the technical and financial outcome of civil engineering and building project. So based on the site investigation, the SI report for the Bolog indicate that the field investigation was conducted from October 10 to October 16, 2014. Various tests were performed both on-site and in the laboratory to analyze soil and subsurface condition. SPT were conducted at 1.5-meter interval or at changes in strata using manually operated auger and mechanically operated shell casing. Undisturbed soil samples were collected using Shelby tubes and were sealed with wax at both ends to preserve their integrity. Disturbed samples were also obtained during SPT process. All collected samples were carefully labeled and transported to the laboratory for further analysis. The sample was stored appropriately for testing and classification purpose. So based on our soil profiling calculation, we got that for the borehole one, it is suitable to use rough foundation, which have topsoil, clay soil, and clay gravel soil. Next, for borehole 2, it is bed footing, which have topsoil, clay gravel soil, clay muram, and clay gravel soil. And the last one is also rough footing, which have topsoil, clay gravel soil, and clay gravel soil. Next is for the soil properties. Soil property refer to its behavior and suitability for various uses. Soil characteristic includes chemical, biological, physical feature, texture, porosity, and moisture content are typical soil characteristic. As you can see, the depth, composition, and characteristic varies on which type of soil.
Self-same Google description. So it should be a table on the left because of the Google investigation at three locations, identify which is BH1, BH2, or BH3, and all Google share the same diameter, 0.4 meters, and depth of 17 meters, and determine from this SI report. The file length for each Google is 50 meters. The variation as a note as Q, which is good, very slightly across the borehole, and with a borehole 1 at 64.8 kilometer per meter square, BH2 67.84 kilometer per meter square, and BH3 at 74.93 kilometer per meter square. So on the right, we have the table display the efficiency range of different hammer types. So for this analysis, we have selected 60% efficiency, which fall within the conservative range for several hammer type, which is a drop hammer, because we use a drop hammer. So this is a grouping look that we guide for our decision for next. The next range of pressure for the diameter, we choose diameter for 200 and it will because 1.11 because our diameter is 450, and then for variable we use then with variable with linear for dense sand and clay because our type of soil, and then for the variation sample variation we use more than 10, which is 1.
Okay, today I will explain about the equation that we use in this case. For the equation we use to establish a for solid foundation on our side, we first determine the correlation between the angle of friction and the standard penetration number. For the equation of angle friction was stated here, and the standard penetration M60 also we have put in this slide. All the borehole depth was 70 meter, and then this is data for the borehole 1 and borehole 2, which is the total M60 required 107.52, and then the friction angle was 166.21. While the total data for the borehole 2 was for M60 was 105.84, while the friction angle 165.63. The data for the borehole 3 we got N60 was 116.76, while the friction angle 168.45. And then we refer to JKR class 1 standard for RC pile. We use the nominal size 150 times 150 mm for our to achieve our maximum JKR working load.
So the slide presents a detailed analysis of surveillance for is on level capacities, and the will provide the data for each layer, including depth, stress, and area. So for Volcker line, we also put the three size layer at depth of 1.6 meter, 8.9 meter, 6.5 meter, and the stress value range from 30.7 8 created kilometers square to 156.54 kilometers per square. And the area for this area we calculate based on the shape of the so which is a rectangle and triangle. And the range the each layer is 24.6 centimeters square to 184.48 meters square. And the value we derived using the rest with the constraints situation. For the Google tool, we will follow a track of 1 meter, between 9 meter and 10 meter. In this case, value range from 20 to 1 kilometer per meter square in the first layer to 145 kilometers per meter square in the fourth layer. And the area value varies from 10.25 meters square to 985.55 meters square, and this computation help to identify the distribution of the capacity within this group. And for group three, we have a full layer we will analyze with depth at 1 meter, 5 meter, 9 meter, and 2 meter, and the total is 70. And in the area, the stress value starts at 90.8 kilograms per meter square and increase up to 167.03 kilograms per meter square. And the area value range from 9.3 square to 220.94 meters square. And this figure are critical for understanding soil properties and their distribution. So in summary, the result from this will give us very good insight into the variability of soil stress in area for different types. This information will include the consideration for the process.
Assalamualaikum and good day. My name is Roshaida binti Omar Yusof. My metric number is CF220219. So today I will continue explain about the calculation till slide number 15. So for this slide is a method which our soil type is clay. So we use the displacement pile is 1.10 cube and non-displacement part is 1.10 cube. Okay, so for the previous slide, we have chosen for the clay for non-displacement. So this is data for a method which is for borehole 1, borehole 2 and borehole 3 that have been calculated and put the value in the table. So for the first borehole 1, the depth is from 0 to 1.6, 1.6 to 10.5, 10.5 to 17. Which is for total L we got 1.6, 8.9, 6.5, CU is 30, 32 and 33. And then for A rated which is we take for the 1 times 10 cube. And then we calculate this table for get the total QS, which is QP is minus 9 CUP, QU equal to QP plus QS, QL equal to QU divided by FS. Our factor safety is 3. So the second table and third table, the second table is for borehole 2, the third table is for the borehole 3. The calculation is same and the safety factor is 3. So in the final result, we get the analysis for every layer of the soil. So for the borehole one, we got the Q apply 2,880. Borehole 2, we got 3,015. Borehole 3, we got 3,330. So the Q all equals to average Q all. So we got 8546 for borehole 1, borehole 2 5711.06, borehole 3 8840, which is all the condition of our borehole calculation is passed. Lastly is settlement checking, which is from the borehole 1, borehole 2 and borehole 3. Our Z is the lowest is 5.3 and the highest is 8.0. Our H is for borehole 1 is 2.8, borehole 2 is 1.6, borehole 3 is 7, and also for all DCC is 0 because the ASCI is 0. So our BG is 0.5 and LG also 0.5. So the conclusion is this analysis is used for settlement is validated by the fact that there are no settlement. Additionally, there is no CC value on this clay layer and no sample has been left undistributed to allow for the collection of new data.
Okay, design consideration with bearing capacity and settlement. Okay, for bearing capacity, clay has a relatively low bearing capacity compared to the other soil types. So, a deep foundation system like piles is typically used to transfer the load to deeper, more stable soil or rock strata. The bearing capacity of a pile foundation in clay is derived from both the friction along the pile shaft and the end bearing capacity at the pile tip. End bearing is only applicable if the pile reach a stronger layer beneath the clay. For safety factor, a factor of safety is between 2 and 3 that is typically applied. For settlement, settlement is another key consideration for pile foundation in clay. Immediate settlement, which occurs as soon as the load is applied, can be a concern, especially in soft clay. However, pile foundations are designed to minimize immediate settlement by transferring the load to deeper, more stable soil. Over time, consolidation settlement can also occur in saturated clay as pour water is squeezed out under the applied load, which may lead to gradual settlement. The rate of consolidation depends on the clay's permeability, thickness, and the applied load. To ensure that the settlement is within the acceptable limits, pile foundations are carefully designed to minimize both immediate and consolidation settlement, thus ensuring the long-term stability and functionality of the structure. Hi, Assalamualaikum. My name is Nur Izzati binti Ismaruddin. My license number is CF20175. Okay, I want to present about design foundation with design consideration bearing capacity and settlement. Okay, the primary purpose of foundation is to transfer the load of the building to the ground in a safe and stable manner. A good foundation ensures that the building remains stable and does not sink or collapse due to the weight of the structure or external factors such as weather conditions or natural disasters. The pipe foundation is chosen for design as it serves as transfer building loads to deeper, more stable strata or rock layers beyond the reach of shallow foundations. These foundations are commonly used when surface soil lack sufficient bearing capacity or when structural loads are exceptionally high or the soil near the surface is weak or compressible to support the loads of the structure. However, the choice of foundation depends on the soil's capacity determined through a detailed soil investigation report. The selection of the appropriate foundation depends on several design considerations, including soil conditions, structural requirements, bearing capacity, and settlement. The foundation needs to be designed in such a way that it can withstand the weight of the building and the force acting upon it. In this case, the subsoil is composed of clay soil as indicated by the soil profile. Clay soil is a cohesive soil with high plasticity index low permeability, low drainage, and significant potential for shrinkage or swelling, which can affect the behavior of the foundation. Designing a foundation on clay requires careful consideration of these factors to ensure the stability and durability. The pile type is crucial that piles are often being the best choice for clay as they provide reliable load transfer through skin friction and annealing. The pile depth is another critical factor as it must be sufficient to reach more stable, competent soil layers beneath the clay. Okay, the conclusion of this project is the investigation of borelog data and soil profiles for the construction site of the new Nalanda University campus in Rajbihar has determined that the soil conditions are suitable for implementing a deep foundation. Based on the soil investigation and analysis, the pile foundation was selected due to its capability to transfer loads to deeper, more stable strata by passing the weak and compressible clay layer near the surface. This ensures that the stability and durability of the foundation under the applied structural loads. Lastly, the pile foundation design for the structure on clay soil is sound and meets the necessary structure and safety criteria as estimate allowable bearing capacity Q allowable, exceeding the applied loads Q applied at all borehole locations. By addressing the specific challenges posed by the clay soil, such as low bearing capacity and potential settlement issues, the foundation ensures long-term stability and performance. This through design and analysis provide confidence in the safety and durability of the structure built on these challenging soil type. Okay, that's all from us. Thank you.